So, our second speaker for tonight is YANIR SEROUSSI. He's a bit of a fixture in the Data Science Sydney calendar. He gave the third talk ever on how to almost win cackle competitions. And I think today is your third presentation here in total. So, from the bio he sent me, he sees himself as a type B data scientist, so more the programmer, software engineering type, which comes probably from the background that he did his PhD in computer science at Monash University. His experience is broad, his talks are always full of surprises and new insights here. He's worked across the entire spectrum, solving tiny little isolated data problems to building production-sized systems that serve millions of users. He's working with recommender systems, text mining, price forecasting, personalization. Currently, he's the head of data science at Car Next Door, and today he's asking why.
Yes.
Tell us all about it. Yanir, the stage is yours.
I will. Does this thing work?
I don't know.
It works like that. Let's see how it goes. This one, right? Yeah. Cool. So I gave this talk like a couple months ago at the Melbourne Data Science Summit. And they've only made a few changes, which put a bit over the 30-minute mark, which I hope you guys won't mind. So yeah, because I haven't made many changes, I thank Phil, who's Phil Riley from Melbourne. And the reason I left this in because Phil sent me this email end of last year, and I'll read it out. Are you doing anything on the 6th of May next year? I'm organizing an event and need a passionate data scientist to tell it as it is. Let me know if you're interested in what you would like to talk about. Hopefully something technical and thought-provoking. So given this email, I came up with the following talk, where we're going to talk about asking the question why for 3 different reasons. First, to uncover stakeholder motives, which is the telling it as it is part of the talk. Second, to infer causal structures, which would be somewhat technical but not too much. And finally, to find your purpose, which some of you may find thought-provoking, some of you may just call me naive and laugh at me. And since we're in Sydney, I'd also like to thank Eugene and Fabian, and as you can see, Eugene doesn't send such exciting emails, it's always used to me. And the rest of the organizers for having me here for the third time in a row. So, all right, let's get into it. Let's talk about asking why to uncover stakeholder motives. So I'm going to run through a scenario which may or may not be imaginary, where we have a client who says that they need a model to predict churn. A younger version of me would get all excited and say, sure, I'll plow for your data and use deep learning or whatever the hardest thing is right now and build the best model ever. It's going to be awesome. A few weeks elapse, we come back to the client and say that the model is ready. It's super accurate and the most predictive feature is tenure with Anthony. Tiber is laughing. He's actually inspired by a story. I won't get into it. To which the client may say, thank you, but we actually don't have time to use the model at the moment. We don't know how to productionize this deep learning business, and our churn rates are not much of a concern, as much of a concern as I thought. And let's just talk again when this becomes a problem. Like, awesome work, thank you. See you later. Now, this could have turned out differently if we had asked why. So I'm going to run for this scenario again. Client comes in, and I'm not talking only about people that are in consulting. It could be an internal client, it could be your boss, and says that they need a model to predict churn. My first question these days would be like, why do you need a model to predict churn? What are you going to do with this model? After a few minutes, in a very optimistic scenario, we may come to the conclusion that what the client really wants is to reduce churn. We don't really care about the model. because they assume that preventable churn is costing them something like $10 million per year. And therefore, they'd be willing to pay for a system that not only predicts churn, but also schedules the most effective interventions to reduce churn and prevent it based on the customer's personal circumstances. To which the client would say, yeah, correct, I'll just build me this system and I'll pay you handsomely. However, things don't always turn out this way. You may get other possible answers to the question of why do you need a model. One possible answer that you may be able to infer, and you're unlikely to hear explicitly, is that the model would look good on the client's performance review. And I'd say, if this is the answer that you infer, just run away and don't deal with these people, if you can help it. Second, another possible answer is that we always use a model, even if using it is worse than random. And I'm not talking about a model for which the predictive accuracy on offline data is worse than random. I'm talking about a model that seems to predict whatever it needs to be predicting, but when you use it to schedule interventions, it actually performs worse than just handing out interventions at random. And in this case, I would say run away even faster, because it sounds like the kind of organization that's unlikely to see business value in data science in the long run. A more legitimate answer to the question of why do you need a model is, if it's a churn model, you want to understand what's causing churn. And in this case, I'd say that you need to be pretty careful with your modeling, because, for example, we've seen short tenure doesn't necessarily cause churn, it's just predictive of churn. Which leads me to the second part of the talk. We're going to talk about asking why to infer causal structures. So I'm going to start with a classic example that I'm sure many of you know, and it's often used to motivate the whole idea of causal inference. And that's Simpson's paradox. And Simpson's paradox, for those of you who don't know, it's basically a phenomenon that occurs where you have a certain trend in the general population that's reversed in every subpopulation. And this sounds weird, but if you look at the numerical example, it will all make sense. So let's say we have some treatment C for a certain condition, and we want, and we're looking at recovery rates, and we multiply it with E. If we look at the entire population, we see that 40 people have taken up the treatment, and the recovery rate was 50%, and 40 people went untreated, and the recovery rate was 40%, which makes it seem like that the treatment works. However, if we look at the subpopulation of women, we see that of the treated women, for the treated women, the recovery rate is 20%, while for untreated women, the recovery rate is 30%, which makes it look like the treatment doesn't work on women. However, if we look at the subpopulation of men, we see that it's a similar story. 60% of treated men recover, while 70% of untreated men recover. So given that we have this data set, and we can't collect any more data, we have someone with this condition, with this illness, and we want to make a decision whether we should prescribe this treatment to this patient. What do we do? Let's say that we don't know the patient's gender. Then it sort of makes sense to prescribe the treatment, because if we look at the data set, we'll infer that the probability of recovery given the treatment is greater than the probability of recovery given no treatment. However, if we know that the patient is female, we may decide not to prescribe the treatment, because the probability of recovery given the treatment and given that the patient is female is lower than the probability of recovery given no treatment and the patient is female. And it's the same story for men. We will decide not to prescribe the treatment if we know that the patient is man. which is, of course, somewhat ridiculous because apart from a few outliers, we know that every person is either male or female, so why not use this information to make the decision? Now, the answer, according to Judea Pearl, who's one of the prominent researchers in the field of causal inference, is that we have to make some assumptions, and it's not enough to, we can't just make this data based on the raw counts. We need to take into account the semantics of the variables. So we could make the assumption that gender affects treatment uptake, and it also affects recovery, in which case we would follow the gender-specific measures and never prescribe the treatment. However, we could get exactly the same data set, but with different variable definitions, where this variable f that we split the population by is high blood pressure, and the treatment affects blood pressure, and blood pressure also affects recovery, in which case the correct decision would be to follow the aggregated measures and always prescribe the treatment. And graphically it looks like this, and this is, there's much more to it, but basically what stands at the core of a lot of Pearl's work is encoding these causal assumptions as directed acyclic graphs, where you have an arrow from x to y if x is a cause of y. But whether you follows Pearl's approach or just doing general regression, it's important to remember that the decision whether to use a certain variable to predict a certain outcome can't only depend on this raw count data that you have. And you always make some assumptions, either explicitly or implicitly, whether it's in what variables to include in your model and what to measure and how you measure it. And this problem actually becomes bigger when you have bigger data, because you're more likely to get spurious correlations and various instances of Simpson's paradox. Now, I've been interested in this field of causality in the last few years, and I wanted to give a very brief overview of some of the different approaches to causal inference. So the first one is the example that we've just seen, uses graphical models, and it's been advanced by Judea Pearl and many others. And the basic approach uses these vanilla Bayesian networks that I find somewhat lacking, because they don't force you to explicitly encode the temporal element of causality, and I don't think that you can really talk about cause and effect without talking about time, because the way we experience the world is that the cause precedes the effect. And that's sort of the problem with the second scenario that we've seen, where it's unclear whether the blood pressure is taken before the treatment, during the treatment, after the treatment. I think that's a bit of a limitation of that approach. And that's addressed to an extent by dynamic Bayesian networks, where you do take into account the time, but with PBNs, it can get hard to model long-term effects and non-discrete time intervals. A different approach comes from the field of economics. It's called Granger causality, and it's a very simple concept where you look at whether past values of x can be used to predict y, and if they can, you could say that x Granger causes y. And the reason why you say Granger causes and not causes is because it's not really causality, and no one really thinks it's causality, but it's a very useful concept. It's more like extending the concept of correlation to include time. More of a latecomer to the field is Samantha Kleiner, who's finished her PhD a few years ago and has since written 2 books on the topic, which are well worth reading. And she uses temporal logic, and her work is inspired by formal verification of hardware and software to encode these causal assumptions and perform causal inference. And yeah, well worth checking out. I've written a couple of blog posts about her work. And what I like about it is that she doesn't really shy away from philosophical discussions about what cause and effect is. And and she uses that to inform her work and test the different approaches to causal inference. However, I haven't used her approach for anything practical, so it's a bit, and a lot of the evaluation in her papers is on synthetic data sets, so it's hard for me to tell how practical it is in practice, but it's very interesting still. Now, no matter what approach you use to do causal inference, there are some limitations that are worth being aware of. And I'm going to go through my top 3 limitations that bother me. So the first one is that there is simply no single definition of what causality is, of what cause and effect is. And you could use, 2 different people could use the same causal inference approach, but get different results because they follow different definitions of causality. And that's because you always need to make some untested assumption in order to perform causal inference. And these assumptions serve as axioms from which you would find further causes and so on. And these 2 causes of frustration, the plurality of definitions of causality and the need for untested assumptions, mean that there's a lot of wiggle room for unreasonable people to raise doubts about the legitimate work of hardworking scientists, and because it's very, very easy to come to different conclusions based on different assumptions, different axioms. And yeah, that's like the whole issue of climate science that I'm going to talk a bit about more later, is that you have these assumptions because we can't run experiments on our Earth. We only have one Earth, and yeah, not sure what I'm saying. Anyway, so given this, you may ask, why even bother with causality if we have all these limitations? Well, I think it's worth thinking about your causal assumptions and properly encoding them, because that does allow you to form plausible explanations, assuming you're dealing with the unreasonable people that will poke holes at every reasonable assumption, and generate stable predictions. It allows you to generate stable predictions out of the model, because you are more likely to avoid relying on spurious correlations and also schedule effective interventions. And being aware of the limitations of causality and how these things work is useful, I think, for dealing with the political implications of your work. And there's always some political implications whether you work for a big organization or a small one or independently. So yeah, since giving this talk last time 2 months ago, I've done some more reading and writing about the topic, and added a couple of slides summarizing my more recent learnings. So first, the question arises of, given that we have to make causal assumptions, how do we come up with these assumptions? And one approach would be to look at various correlations and associations and follow the Bradford-Hill criteria for separating association from causation. Now, for those of you who don't know, Bradford-Hill was an epidemiologist who's famous for many things, about his work on experimental design and his work on showing the link between smoking and lung cancer. And he suggested these criteria over 50 years ago, and they're still in use and relevant today. Now, I'm not going to go into each and every one of these criteria, but what's worth mentioning is that it's not, you don't have to satisfy all of these conditions to prove causality, and it's also not enough to have just one of them. So for instance, if you look at the link between smoking and cancer, there is a very strong correlation between smoking and lung cancer, which is satisfies the first criterion, but it's very hard to show specific cases of cancer were caused by smoking because it takes such a long time for cancer to develop, and you can't say that, oh, that case of cancer was definitely because of the smoking. And one important criterion is that of experimentation, the eighth one, which I'm going to talk a bit more about. Now, experiments, Dario is just here laughing. Experiments are great for showing a causal link. And if you were here 2 months ago for Tiberio's talk, you may remember that he talked a bit about the virtues of experimentation and said that if you can run an experiment, you should, because trying to do causal inference with only observational data is dirty and messy, but if you have experimental data, everything becomes much easier. Now, I completely agree with that, but it's also worth remembering the experiments are neither easy nor perfect. So, for example, we have A/B testing. For those of you who aren't familiar with the concept, it's basically used in websites where you show two variants of a page or your website to visitors, and you're trying to so like the variants are allocated randomly. So given a visitor, you flip a coin and either show them variant A or variant B, and then you measure some metric of interest such as sign up to your website. Now, that's a very simple experimental design, but there are quite a few issues with it because there are different selection biases because, for instance, you may collect data over, and you have a high traffic website, you may collect data over an hour and you have 10,000 people, but it's not the same as collecting data over 2 weeks and have 10,000 people again because you may get time of day and day of week effects. And there are also issues with multiple comparisons if you're using certain statistical significance tests, because unlike lab experiments where you would decide on your sample size in advance, collect your data, and then run the analysis at the end on exactly the sample size that you've decided, in A/B testing, since you keep getting results, there's the temptation to stop the experiment as soon as you get statistically significant results. And if you're using fixed horizon statistical significance tests, then you will end up with a lot of false positives, a false positive rate of close to 100% if you're completely doing it wrong, which is not what you want. You need to account for that. Another example of where experiments are not perfect is the big three of smoking, climate, and nutrition, where it's either impractical, unethical, or impossible to run perfect experiments, and you have certain various corporate and political interests that push against, that keep requiring more and more evidence to actually make a change. Say that everyone, I think, these days agrees on that smoking causes cancer and is hazardous for your health. But if we look 50, 60 years ago, because you can't run a randomized controlled trial where you would force a certain group of people to smoke and have another control group that wouldn't smoke, you can't conclusively, so to speak, provide experimental evidence for the causal link between smoking and cancer due to ethical reasons. And as I said, in the case of climate change, you can't have an experiment where we have another Earth where we would try maybe not to emit as much greenhouse gases as we do on our current Earth. But you can run smaller scale experiments. For example, on the greenhouse effect has been reproduced in the lab in the 19th century, which of course makes it ridiculous to think that the climate science is a conspiracy by the UN to bring about the socialist world government. Now, even if you can experiment and you have a very well-designed experiment, it's still important to take the results with a grain of salt, because as shown by Leibovici, few years ago in a nice randomized controlled trial where they had, it basically showed that remote intercessory prayer said for a group of patients is associated with a shorter hospital stay and shorter duration of fever in patients with a bloodstream infection, even when intervention is performed 4 to 10 years after the infection. And the results were statistically significant. It got published in BMJ, which is a very prestigious journal. But yeah, it's not enough for reasonable people to think that if we pray now for someone who got released from hospital 5 years ago, it would make them have a shorter length stay at the hospital. And that's where we would go back to the other Bradford-Hill criteria and look at the criterion of plausibility. And based on our experience of the world, it's implausible that you can cause a change in the past, at least for all we know for now. All right, enough about causality. So I've talked a bit about these useless models and about dealing with politics, and I think it's important to ask yourself why, to find out why you're doing these things, and because no matter where you are, there will be some politics and there will be some unpleasantness. So it's important to do things for the right reasons. And I'm going to make it a bit personal and talk about stuff I've done so far. So I started off, did a computer science degree at the Technion in Israel, because I thought it's an interesting and portable profession. I knew I wanted to move out of Israel, so I thought computer science is a good way to go. And my first job as a student was with Intel, where I only wanted to get some experience, and I just wanted, I told them, I just want to write software. I don't care what kind and what it does. But after a year with Intel, I was working there on like software testing of hardware testing tools. I didn't find it very exciting. So I ended up moving to Qualcomm, where because I wanted to write more interesting software that actually makes it to production. But I found the whole field of software engineering somewhat limiting, and I wanted to leave Israel, as I said, so I ended up doing a PhD at Monash, because I was, and the topic of the PhD was in text mining and user modeling. Nowadays they brand it as data science. I did a PhD because I was just interested in AI and NLP. During my PhD, I did an internship with Google because I was concerned about staying in Australia, and I wanted some Australian work experience. And I thought Google would look good on my resume. But when I finished my PhD, I decided I don't really want to work for another big tech company again, so I ended up with a small startup called Givable. Well, again, wanted to stay in Australia, and I was pretty happy with that opportunity because Givable was basically a recommender system for gifts based on social networking data, and was related to my PhD, which part of it was on recommender system. However, Givable didn't last that long, and I needed to, it shut down after less than a year, and I needed to move to Sydney to be with my partner. So I ended up with a company called Next Commerce, where I actually got to keep working on the same code base as Givable, working on a recommender system as a service called Hint, which was basically a service that a widget that merchants could embed on their website, and it would recommend products to visitors. However, yeah, in both the case of Giveable and Xcommerce, I didn't really care about what the company was doing. I was more interested in the technical side and in staying in Australia. And I also didn't last that long at Nextcommerce, and because there were like a lot of internal politics which I won't get into. So after a year left, and I decided to do some consulting work and also work on my own projects. And the idea was to have some kind of lifestyle business where you get a passive income and have some independence. And that was all right. But my main idea for like a passive income project was in the field of e-commerce again, and it was a price comparison engine. And I built it, and it worked, but I realized that it would take me a few years to actually make it into a source of income, and I didn't really want to spend a few years doing that, because I haven't learned my lesson for doing something that I don't care about, so I ended up shutting it down and decided to find a new full-time job, and that's how I ended up at my current position, which is at Car Next Door. And for those of you that don't know, Car Next Door is basically like Airbnb for cars, where if you have a car, you can rent it out for people in your area when you don't use it. And if you don't have a car, you can hire out your neighbor's car for affordable prices, and you should all check it out. And yeah, what I really like about the company is that it's like, the reason it was started was because Will, the CEO, wanted to reduce waste and do something positive for the environment. He was also in a business that he didn't really like. And it's a pretty interesting time to be in, like the company is growing and there's interesting data stuff to do, so I'm pretty happy for it now. But yeah, I find that either in my software engineering path or in my data science path, and also from speaking to many other people, that there's this sort of natural progression for technical people where you learn the skill and then you want to just find a way to apply it. So like in the software engineering, I just wanted to write software, or as a data scientist, I was just, I want to build predictive models. But then as you get better at doing that, you sort of get bored, and then comes the question of why do I even bother? Why am I doing this? So, in summary, I think it's worth asking yourself why you're doing these things, and what you're doing, what's the meaning of what you're doing to you. Keeping in mind that there is no objective definition of meaning. What's meaningful for you is meaningless to me. It always turns on that. It's also totally fine to be in it for the money or the experience, but it's worth being honest with yourself, at least. And also keeping in mind that money doesn't necessarily compensate for disability and suffering, and for this sort of lack of pride in your work that can either come from building models that are basically useless, like the churn model that we built and just got put on the shelf, or working for a company where being successful in what you do changes the world for the worse as you see it. And I think that the reason I'm saying it here and saying it before is because I think that most data scientists do have a choice, especially in today's market, and it's worth asking why to make sure that you choose well. And that is all.
Beautiful presentation. Thank you very much, Yanir. Are there any questions? I'm sure there are.
That's okay, I can just...
No, you don't have to.
Hi.
Hey.
Okay, that was...
You go.
Okay. If I wanted to learn more about causality and things like that, what should I read or Google or whatever?
Well, I've written a couple of blog posts on the topic. Go to yanirserussi.com. But I really recommend like Samantha Kleiner's latest book. It's pretty high level, and she contains a lot of references that you can follow and continue the journey based on what your interests are. But she gives a very good overview of the philosophy and the whole, but also the causal inference part of the more technical stuff. Yes.
Professor Susan Athy from Stanford was out here last year for KDD and has done a lot of work on causality, and because I think it's cool that an economist actually posts code on GitHub, I thought I'd ask if you thought there was anything that we could learn from the economists about causality.
Yeah, I think there is a lot. Like I'm actually reading mostly harmful econometrics now, mostly harmless shit. Not harmful, harmless. But yeah, like Pearl claims that his models supersede all of these other models, like the potential outcomes by Rubin and all those other ones. But yeah, there's definitely a lot to learn from it, and I think that one thing that I'm not an economist myself, but one thing that you see in a lot of the economist work is the element of time is definitely not ignored. And, the grandeur of causality comes from pure economics. So yeah, there's definitely a lot to learn from it.
I have two questions actually.
I only have one.
First one being, in terms of the causality aspect, I think, given the debate between statisticians and the inability to define causality, do you think that when the layperson gets statistics, and I say lay as in someone who doesn't pay any attention to statistics, and now with Donald Trump and all the elections where no one cares about statistics, do you think we should try and do a better job of getting either people educated or helping them understand why statistics are important and some causality?
Yeah, like that's actually something that I'd like to get better at, like explaining uncertainty to people, and also comes from Tiberius. So the whole concept of uncertainty is people people tend to just take the mean and think that's like a fixed sample, and just like getting people to understand it. So thinking in a more Bayesian way of like these are rows from a distribution, your conversion rate this month and your conversion rate next month, whether it's actually different, if it's 3.2 or 3.1. Yeah, it's like, I think there's hope. Like, actually Eugene's not here. The talk he gave at the Melbourne Data Science Summit, he talked about how back in the day, basic arithmetic wasn't required to get by in the world, and but that's obviously changed, and I think that some basic knowledge of statistics and uncertainty, and being at least aware of how to do this causal inference is going to be very important, because it's just I think this. Yeah, I really like the book. I think that sort of stuff needs to be taught at like primary schools, because it's just like you get constantly bombarded by all these scientific findings and in popular media, but people don't really have the tools to critically think about whatever the latest headline is. That makes sense. I agree with you, I think. Yeah.
The second half is a short one.
Okay.
What do you think of Tesla's master plan?
Oh, I really like it. It's awesome. It's like last thing is like we need to make people, we need to enable people to share their cars. Excellent. Excellent news for people like that. Well, in the whole car sharing. Yeah.
Excellent topic, and I think we need to think in this direction actually. There's more and more sort of holistic wisdom thinkers are pointing to the importance of questions, and somebody said if you have like whatever number, 90% at least you should spend on defining the problem, asking questions, because at the end might be simple by not having to actually solve the problem, which might be actually causing a bigger problem rather than. So should we actually? So mathematics is the foundation for most of the sciences. Probability is the gray level area where we don't understand fully. I think that philosophy is the highest level where you can't apply all these methods easily, but we need to define the problem on a sort of high level rather than going to technical solutions too early.
Yeah, I agree. It's also like it's out of my laziness, I think, like this whole like asking why.
That's kind of a question about the experience.
Yeah, yeah, I find that like it does help pushing back. So say if you're doing a lot of useless work, where someone tells you, "Oh, we need them all," like even even if their answer is good, it's worthwhile understanding the motives of why people are asking you to do X. And that's an important part in the problem definition. You may end up redefining the problem based on that conversation. So it's not only just pushing back to be painful. Yes.
Yeah, so thank you for sharing your experience, and it was interesting to hear about both big companies and small companies. And I'm quite interested to hear a little bit about maybe any advice or key insights from your approach with startups, because they might have a lot of data, they don't have a data lead before maybe your presence. But what's the right approach to building a strategy? I think you've talked about asking why as being one of those things, but yeah, I'd just be really interested, given seeing both the big companies and the small ones, how do you start a data strategy in a small company?
Well, I think that you find there are lots of low-hanging fruit in a small company. Like one of the first things I did at Car Next Door, they were like, which wasn't a very data sciencey thing, but they were tracking a bunch of metrics in various spreadsheets manually, and I was like, okay, we need to be able to like have all this data feeding in and be able to recalculate these metrics manually. And I took the opportunity to also ask about like why are we tracking each metric and how is it actionable and how will a change in this metric change our behavior. So yeah, which is something that you can't do in a big company like the sort of say it's banks that they're measured by external metrics and they're very much ingrained in the business. So I think it's like every company would be different, but yeah, it's just mostly talking to people and figuring out what the most pressing issues are, and yeah, and you sort of get that like there is the importance of domain expertise can't be understated. It's sort of something that you pick up as you go. Does that answer your question? So
yeah, actually I've got a comment on your presentation.
yes.
So when you say answer why, from my perspective, just by the way, I worked in a startup and now I work in a corporation. Just so you know, my experience is not biased. Well, it's possibly biased based on individual companies, but not saying that I'm in favor of corporate or startups. So my comment section, when you say answer why, first of all, from my perspective, it's more like part of your sales skill set. So how are you going to sell your solution to your client, no matter it's an external client or an external client? And sometimes, or actually most of the times, the answer is not so obvious. Because first of all, especially if you work outside, you can't really see the whole picture. And the second thing is that if you don't have subject matter of expertise, then it will be very difficult to understand the business context. So it's not so obvious to answer that question. The answer might be very simple when you find the answer, but the process of understanding and answering the question is not very obvious. And the other thing is that I tend to ask what my clients are going to do after this model.
Mm-hmm.
What are they going to do about it?
Mm-hmm.
It's because clients may not, they may not think about why we are doing this, but if you ask them what you are going to do about it, they may tell you a bit more information.
Mm-hmm. Yeah.
Thank you.
Very good. Good point. I think we're through with questions.
Awesome.
So please join me in thanking Yanir again. Thank you very much.
Hi, my name's Greg Capel. I'm a data science search specialist focused on the fintech startup space, so it's quite interesting that Yanir got up and started talking about that. I'm wearing two hats, one with a company which is a VC organisation called Reinventure, and also my own company which is Fintech Search. So if Yanir's inspired you about the startup space and what you can do with modelling and move away from probably large corporates, please come and talk to me. I'll be over on the right hand side.